Hi everyone, this is Miss Casto, and today we're going to be talking about the infinite chocolate bar trick. If you haven't seen this video on YouTube yet, you should totally watch our video because we're going to tell you how you can take a chocolate bar and cut it in a certain way that you can have one piece of chocolate, put it back together, and nobody will be able to tell unless they look really close that you've taken a piece of it. So this explanation is going to talk about seam carving, and if you are one of those people who may not like chocolate and you don't want to waste a chocolate bar doing this, we're going to have my friend Dr. Menon. He's going to tell us how we can do a computer simulation of this very trick. I used a different chocolate bar the second time, so it's just the store version, like the store brand version, as compared to the Hershey brand. So it's not cut into the same 4x4 sections that this other one is, but you can tell that it's almost the same size. So this is an example of a real world fraction when you're going to need to know how to use equivalent fractions to know where to cut on this. So my new chocolate bar is 2 in a column and 4 in a row. My Hershey chocolate bar that I'm going to tell you where to cut is going to be 4x4. So if you use your length times width area formula, then you'll know that the Hershey bar has 16 pieces and this bar is 2 times 4. That's only 8 pieces. But if I divide each of my 8 pieces into 2, I'll get 16. So 1/8 is equivalent to 2/16 because 1 times 2 is 2 and 8 times 2 is 16. So I can divide these pieces into 2 and get 16 pieces just like the other Hershey bar. So substitutions are absolutely allowed. Now here is my example of the infinite chocolate bar. So in order to get my knife hot, I soaked it in some very, very warm water, and I'm hoping it will work. So we're going to make a cut, the very first cut that I showed you, from the top left-hand corner to the bottom right-hand corner. Let's see how it goes. It is melting the chocolate, so I got it warm enough, but I notice it's already starting to crack here, so I'm going to get my knife a little warmer before I cut again. So I'm going to stick it back down in my water, and then I'm just going to go slow and maybe cut. Ooh, okay. Now I have my first diagonal line, and I remember I have to cut off the top along this line here, right underneath the first row of chocolate. Or if you're like me and you bought a cheaper or store brand chocolate bar, you might have had to make your own. And look, I already cut it there. That's okay though. Just going to be very easy in cutting the rest of it. There we go. Okay, so now you should have your 3 pieces. The one at the top, this chunk at the bottom, and this one here. So this piece here is going to move to the bottom, and this one is going to slide to the top. And it looks like I need to cut off a little piece here, just so it will be butted up against there, okay? And now when I put this one here, you can see my extra piece here that I can eat. So you can see that I have this extra piece here, but I still have a rectangular chocolate bar. And if somebody's not looking very close at it, they might not even know that you took one of these pieces away from here. So this is the full Hershey candy bar, and I'm going to invite Dr. Menon to talk to you now about how this can be simulated on your computer.
So this one's done using an algorithm for seam carving, which was published originally by the authors of this paper. All right, and they have some very nice videos here. Here's the web link up there on the top left. And essentially what their algorithm does is a seam is identified on rows and columns, depending on which direction you want to shrink an original image, which would be least missed, so to speak, and then removed in a manner such that the overall image may be shrunk by the removal of that seam. Okay? So in one example, the seam that we have here, all right, may be a bunch of vertical lines, all right? And those vertical lines are going to be removed in order to get this new grid. So let's look at the old grid and the new grid carefully. Notice how the leftmost vertical column does not change in width very much, whereas the rightmost column changes the most, and the next two columns are affected in a more diminished manner as you go towards the leftmost column, right? So seams were removed in order to reduce the width of this chocolate, and as such, that is approximately the area that would have been occupied by one little rectangular piece. Okay. So to give you a sense for how all this happens, you can actually implement seam carving using Python code and experiment on it for yourself. Okay, so in one example, this is some Python code put up on Google Colaboratory, which implements the seam carving algorithm. And what you see here is a vertical snapshot of the 4x4 chocolate grid, all right? And the stepwise approach in order to establish the ideal seams to cut in a manner such that the removal of those seams are going to be felt the least. Okay, so in this example, the red line represents a seam that was identified by virtue of something called an energy map, which was created based on the gradients of intensity in the image, and a cumulative energy map, which is based on this original energy map. Okay, and then subsequently you can do this in a sequence. You can identify the minimum seam line on the first image and reduce it by a certain number of pixels, and reduce it further, and reduce it further, and reduce it further by the same amount each time. And in this particular example, you can see that as I reduce it further and further and further, it's almost like doing that seam carving exercise over and over again. I'm landing up with a 4x4 grid each time, but each time the overall appearance of this particular grid has changed into one that looks more mashed together. While the initial changes were less apparent, right, in terms of the change in the overall orientation, appearance of the chocolate bar, as you remove more and more seams, the change in appearance becomes more and more apparent. Okay, you could remove seams along vertical lines or horizontal lines. Here's an example where I'm removing vertical lines and making the overall chocolate narrower and narrower, while again retaining the 4x4 grid structure. Okay. So overall, what we have learned about is this idea that area is always preserved. Okay. Whereas appearance can be maintained by appropriate carving out of regions of a two-dimensional image that are going to be missed the least. And as such, this approach of maintaining appearance while getting rid of some area of an original image is known as seam carving. And a very particular exercise in that logic of seam carving is what we tried out with regard to the Hershey chocolate bar. Hopefully you found this interesting.